Good morning, everyone. Thanks for attending this early morning session after a spooky night. I hope that all the potions that were brewed by the witches had their expected outcomes and no one got killed or abducted by the pirates. So today we have one presentation and 3 lightning talks. After the session, it is very important to let you know that Ondrej will be presenting the final result of the general meeting. So please do not leave the room immediately. If you want to grab a coffee, please go ahead and come back. So our morning's first speaker is Birge-Lee, who will be talking about global BGP attacks that evade route monitoring. Henry.
Hello, everyone. My name is Birge-Lee from Princeton University. Today, I'm going to be talking about global BGP attacks that evade route monitoring. This work was done with Jennifer Rexford and Maria Postolaki, also at Princeton. So let me begin by motivating the problem. What is BGP monitoring and why is it important? Well, I think of BGP monitoring as using a combination of public and/or private data feeds to observe global BGP updates. And monitoring is really important because it can not only be used for real-time responses to attacks, but it's also a way we have to identify BGP attacks after the fact. And as high security routing measures like BGP-SEC are taking a little bit to get adopted, I think monitoring is really important in the BGP ecosystem because essentially this is our way of finding out what's happening and detecting attacks. So with that in mind, let me give a little bit of background also on stealthy BGP attacks. So why is it interesting that an adversary can have a stealthy attack? Well, if you think about it, if we're relying on monitoring for attack detection and mitigation, if an adversary can make their attack stealthy, they can evade these defenses, and then their attack can sort of go on a lot longer, or maybe the hard resources they had to invest in that attack will not get burned quite as easily. So I think this is a really important problem. And it's also been shown to be possible in sort of a variety of previous works. So at this point, I think it's very important to clarify terminology. So what do I mean by a stealthy BGP attack? And when you dig down into it, there's actually many different metrics by which an attack can be stealthy. So the first one is kind of how much of it sees your route. So you imagine if you were to launch an attack in a small isolated geographic region, maybe people wouldn't make that big a deal. It's like, okay, 5% of connectivity or something is lost, but maybe stuff will go on as long as happy eyeballs. I'm not particularly focusing on that today. The other one, which has been a major focus of my research, and I think the GRIP talks from Georgia Tech will shed light on, is do you have algorithms that can pick out this attack from the noise of benign BGP updates? And you can imagine an attack could be stealthy because you could make it look like all the BGP updates that are happening every day. Super interesting topic, but not what I'm looking at today. The other interesting one is, okay, so you can have attacks where actually the people who are using the malicious route, so networks sending traffic and sending traffic to the adversary, don't actually know that they're using it because that route, the malicious route, is not in their own network table. We also achieve this by this attack, but the primary definition of stealth I am focusing on today is, do BGP monitoring services see the route? So essentially, on the long list of BGP updates that are generated by route views and write bris, does the adversary's BGP update get added to that list? So we consider it stealthy in this context if it's not on any of the monitor's feeds anywhere. Also, I think this is fairly common nowadays, but in terms of attack terminology, there's sort of 2 paths an adversary can go. They can either announce the same prefix of the victim that they're attacking. So this data center on the right side is operating out of 222/23. In the equally specific prefix attack scenario, the adversary just announces that same prefix. In the subprefix attack, the adversary announces a longer prefix, presumably one that has some critical resource in the data center on it, And subprefix attacks largely get global preference because it's a longer, more specific match, longest prefix match routing. Okay, so with that in mind, I want to talk about kind of the state of the art for where the community stands on stealthy BGP attacks. I'd say there's largely two camps. Camp one is you can launch an equally specific prefix attack and then do a whole bunch of stuff, including communities, AS path poisoning, and then also just announcing to very few neighbors to avoid all of the public monitors. So there's actually quite a lot of ASs that are providing data to monitoring services, and they can actually all be avoided. So this is possible. My work, as well as previously presented work at RIPE, show that you can do this. The downside is that, as I mentioned, there's actually a lot of monitors out there. So once you've chopped up the internet enough to make this strategy work, you're really only announcing over, say, a couple of peering sessions. It's not like a huge chunk of the internet that uses your route. And then also, like, the people that do use it, it actually gets installed in their route tables. And so, you know, if you're able to get access to those or something's going on in an investigation, you can find it there. The other interesting one, I think came up sort of in more recent literature, is that you can actually just stop the attack from spreading to the people that are using it. So you pretty much have to do this with a subprefix attack. It exploits sort of routing with different prefixes. So say there's a /23 that carries it to a provider who happens to have a /24 and then kind of reroutes it. So the victim doesn't actually know that they are using a malicious route. Super interesting, but in the traditional sort of subprefix context, that prefix will spread through the internet largely uncontested. There's no victim announcement of the same prefix length. And as a result, like, you see this attack at many, many public monitors. So I also want to talk about a real-world stealthy attack, and this is an attack that actually happened some years ago. An adversary established a direct peering with Yahoo Mail at DE6, and it just announced its malicious routes over this direct peering. So no transit, it just sent the malicious routes to Yahoo Mail, and this did successfully evade all BGP monitors. Eventually, believe it or not, this attack was used for spam email sending. Eventually, the true victim owner, after many complaints from Yahoo Mail, got in touch with the Yahoo Mail network operators, and they were able to find out that Yahoo Mail had this route in their table that wasn't being announced by the prefix owner. So they were able to catch that. And also, it's worth noting this is a very hyper-localized attack. Like, Yahoo Mail was the one AS on the internet that was routing traffic incorrectly. For most purposes, this prefix was sort of reachable and still doing okay. All of this together, I think, leads to kind of the current understanding on stealthy attacks, which is that although you can make attacks that are sometimes completely stealthy, these attacks can only affect, you know, at most like 2% of the internet. So this is out of a previous work in IEEE Access, and they were looking kind of at these selective neighbor announcements and poisoning. So I think this is in generally true, but today I would like to present an attack that can affect the vast majority of the internet, is seen by absolutely no BGP monitors, and not even the networks that are going to be sending traffic down this malicious route see it in their route table. So I think it's really important to step back and understand that all of the mechanisms we have and have successfully used to catch these BGP attacks can be evaded by this attack. So now let me go a little bit into actually how do you launch this attack. So the key insight is to have the adversary flag their route with a community known as no export. For those of you who are not aware, communities are 32-bit tags that you can attach to a route. And one of the many things communities can do is determine how downstream routers will go and repropagate your route. The RFC that introduced BGP communities introduced 3 well-known communities. One of them is this no export community. And it essentially says, do not propagate this route outside of your own AS. So the route propagates within the AS, but when it hits an AS boundary, you're supposed to suppress the output. And it's important to understand that this is actually baked into most routers by default. Because it's in the RFC, routers that support communities tend to have the functionality to honor the no export. They know what an eBGP session is, and then they suppress on those links. But Write risks and route views, the way they actually get the data that they put into their BGP feeds is with eBGP sessions with major networks. So to the routers at those networks, they think that's an eBGP session. As a result, they go and they apply the no export community and they don't send the update to write risks and route views. And this, I think, is a large deviation from previous work in that previously, we had always assumed that if a network that was providing data to RIS had a malicious route in their table, that route would be sent to RIS. We would see it in the update feeds. Obviously, if it's heard but not used as best path, that's a different story. But if it's selected as best path on a major network that's sending data to RIS, we should see that in the update feed. But with this technique, we can actually put the routes in those networks and still hide them from RIS. And as I said, this makes us be able to be much more stealthy than or much more effective than the previous work on stealthy attacks. Just to visually demonstrate this, on the left side here, we have sort of the status with prior works that if Cogent 174 selects a path as best path, it's going to send that over its eBGP session to write RIS. They specifically peer with RRC25, and this is an eBGP session. Write RIS establishes their sessions out of 12654. So it's like another AS to Cogent, but then it gets appended to the write RIS, update logs. If the adversary tags their route with no export, seen on the right side here, the route can actually enter the Cogent table. Cogent can use it as best path, but will still suppress on this edge to write RIS. So now you've gotten the route into a major backbone, even a global backbone, but it's not in write RIS. So what are specifically the steps for launching this attack? First, it starts by the adversary announcing a subprefix of the victim's prefix, and ideally to a major transit provider that's going to be en route for a lot of traffic. Now, I understand that major transit providers tend to have prefix whitelists specifically on their customers. I'm going to talk a bit about that later. I'm not addressing that right here. Let's assume that the adversary somehow bypasses those. Then the adversary attaches the no export community to their announcement. And as I was mentioning, currently monitoring services are run over eBGP sessions, so the default behavior in routers is to suppress at these edges. And then finally, you get this phenomena where a major transit provider has the route installed but has not exported it to anybody. And this is most effective if you target your victims upstream. So if the provider is being used for the victim's traffic and you target that network, then you can get near 100% of the internet using the attack. So I want to take a brief pause to mention that everything I'm about to talk about was done completely ethically. This is largely a hijacking ourselves approach. So this is our own IP space. All the nodes, including the ones I'm using as the adversary, had authorization to announce this. So we did not test the social engineering or sort of filtering mechanisms of any major networks. We had authorization to announce this prefix, and there were no real services on it. We were mostly studying route propagation and whether it would propagate to monitors. So in our benign setup, we announced this IPv6 prefix from a data center in Silicon Valley. The data center had Cogent 174 as an upstream, and then we had a test client in Sao Paulo, but also effectively the attacks were all global, so all over the world was affected. We began with a benign, or control case, not benign, a control subprefix attack. So we just announced a more specific of the adversary's prefix. This was effective in the data plane, so the traffic from Sao Paulo was being routed to the adversary. But then, of course, we looked in the control plane, and this was totally visible. So this is a Birge-6 dump from the Sao Paulo client, and it shows the /48 in the client's table. This is Cisco Crossword Cloud. We had configured it to throw an alert if we saw a subprefix for that /47. And the active there, that means that it did see the subprefix. There was an active alert. And then, obviously, for this venue, we were subscribed to write RIS. And if you notice peer ASN 174, so this is actually coming directly from Cogent's session with write RIS. Highlighted in red, you can see the /48. So as we expected, all of our monitoring systems were working correctly. We then tagged the route with the no export community, and we actually did not use the RFC defined version. Cogent has their own specific version, which is 174.990. With the 174.990 community, the route didn't spread beyond Cogent. So none of the monitors, and even the monitor connected with Cogent via direct link, got this announcement. But the data plane traffic from the client in Sao Paulo, we confirmed was being rerouted to the adversary. So going through our monitors again, the client still saw this /47. It looked like its route table had never changed. Crossword cloud threw no alarms. And then our ripe risk feed was just empty. It looked completely like routing was stable and normal during this attack. So we can confirm actually that this attack successfully hijacked almost 100% of the internet. We did this by selecting a sample of 1,000 ping hosts. We set the source IP of our ping scan to inside the hijacked net block. So when these hosts generated a response, it would either go to the victim or the adversary, depending on how that host's network was routing traffic. In the scan, 100% of responses went to the adversary. So every host we could find was routing traffic to the adversary instead of the victim. And I should mention this was as expected because the prefix owner exclusively used Cogent for transit. So they had one provider, we put the malicious route in that provider. If you're interested in seeing a video demo of this, you can visit it at this link. So we wanted to move beyond just a single isolated case to look at the viability of the attack in the wild. I want to thank our partner networks we worked with, including RGNet, NJ Edge, which is Princeton's provider, and Princeton, the OIT office. And we were able to test these 4 major networks using their support. What we found is that all of the networks honored no export or some specific variant of it. All of them had a monitoring session with ripe risks. When we attached no export, they all stopped exporting the route over the monitoring session with ripe risks. We also tested this in Thousand Eyes and Cisco Crossword Cloud, and we also noticed that they were no longer able to see the route once it was no export tagged. You also might be realizing now that while I'm talking about no export, that also limits the spread of the adversary's malicious route because you have to go one network at a time. It's not going to propagate from network to network the way traditional BGP hijacks do. So how much of the internet can you actually get? Well, if we ran simulations of AS paths between 150 random source destination pairs from the CADA topology, and just assuming an adversary installed their malicious route in the 4 networks from the previous slide, they would be able to hijack 23% of those paths. So 23% of them had one of those 4 networks on path. If the adversary instead operated more strategically and chose the top 5 ASs by CADA customer cone size, so essentially how many customers and customers do you have in that AS, looking at the top 5 from that metric, you improve this number to 39%. So as I was mentioning, this is a pretty big difference from the sort of 2% that previous work was looking at. And it's largely enabled because you can now put routes into the large networks that are providing ripe risk data and not have it noticed. And obviously, if you just go and poison the routes of all of your victims' transit providers, then you get up to near 100% like we did. I think it's also worth noting that this requires a subprefix attack, and one of the best tools we have to prevent subprefixes is RPKI. Essentially, when you write an ROA, you specify how long that prefix can be announced in the global route table, so the maximum permissible length. But there is sadly one flaw that happens a lot with ROA configurations, and I think it's justified by networks wanting flexibility, but a lot of networks, I should mention we're at very good coverage now at 50%, still 50% not protected, so it's quite relevant still, but we have good ROA coverage. What I was trying to get to is that many networks improperly configure the max length, so they want to have more routing flexibility. They configure a max length that's longer than what they really need at the moment. So if you're announcing a /23, but maybe you're going to deaggregate in the future, you might have an ROA that says /23 up to maximum length, /24. But that means an adversary can just sneak in there announce that /24 uncontested and launch a subprefix hijack. When you kind of take all of these factors in together, the partial coverage, and then the fact that some people have max length wrong, you know, a previous paper of mine at Usenix Security looked at how many domains actually had all of their IP prefixes somehow protected against subprefix attacks. We came out with something around 30%. Domains have a lot of IPs as well, normally DNS and A record providers. And honestly, it was only about half of these were really protected because of RPKI. The other half was just because they ran everything on /24. So that's kind of the good old school way of stopping subprefix attacks, but obviously not good for route table size. So RPKI progress is really, really great. We need to keep doing that. But I personally think that doesn't, in the short term, do much to change the viability of subprefix attacks, which will remain a threat for the time being. And then also, I know I mentioned prefix filters. Prefix filters are incredibly important. Know your customer is incredibly important. Like, all of this is the front lines. It's just that I think we also need backup because, yes, sadly, major tier 1s will occasionally propagate a malicious route. These are just some nanog list examples, if you will. But this is definitely something that happens. Even the best tier 1s with the best sales teams and the best know your customer can potentially be fooled by a creative, determined adversary. So I really think we need to rely on this, but also have cryptographic measures, backups, and good monitoring visibility in addition. So as I mentioned, I would really like to improve this situation, and there are very concrete countermeasures that networks can take. So at a high level, the countermeasures revolve around this idea that a customer should not decide whether or not you send a route to route monitoring. Like, I, as an ISP customer, I shouldn't say, okay, I'm giving you this route, but please don't tell RIPE-RIS about it, you know? And there are several options for this. I'd say kind of the most straightforward is at ingress to a router, translate the RFC no export community into something within the local AS community namespace. And then on the normal BGP peers, you now have flexibility to decide how you interpret that community. And for normal peers, you interpret it the same way the RFC specifies. For RIPE-RIS, you send all the routes, even if they have the community tagged. Option 2, which I've had some networks interested in, is just move the sessions to IBGP. IBGP is not affected by these no export communities. This is being used by Kentech, so there's some precedents of industry using this. There's a minor vulnerability still with no advertise, but we've now moved the attack from localized to a single AS to localized to a single router. So that's a much, much smaller attack vector. I'd say the long term, and many people bring this up, is we should move the monitoring to BMP. That would be really great. I think the engineering efforts behind that on both the RIPE-RIS side and the network side still a little down the road, but probably the proper long-term move, because then the routers fundamentally understand the difference between a monitoring session and just another BGP peer. And then also kind of as a middle ground, you could imagine, like, it'd be nice if there was a flag that you could put on an eBGP session that just says, oh, this is actually a session for monitoring. So it'd be neat if there's a vendor support flag. Obviously, this requires a vendor to put it into their implementation. Just briefly, this is kind of a bird-like configuration for a hypothetical AS1234. I apologize if you own AS1234. But you can imagine stripping these communities at import, replacing them with sort of these AS-specific communities that don't have the same baked-in behavior. And then on BGP neighbors, you match on the AS-specific communities. But for RIPE-RIS, you just have a blanket accept rule. The other one, as I mentioned, is to move the sessions to IBGP. So this is just replacing with IBGP. And in addition to next hop self, there are several things like local pref and metric that you could filter and remove from those routes before you sent them to RIPE-RIS. As I mentioned at the bottom, I think it'd be really great if the RIPE NCC admins considered IBGP sessions. It is being used by Kentech right now. I have interest in deploying these countermeasures at the US RNE networks, particularly ESNet and Internet 2. But I'd really like to extend the invitation more broadly to any network that are interested in mitigating this at your own network. please, please reach out to me. If you are interested in more details on these attacks and more measurements, this is the technical report we published on arXiv at the bottom. So I really appreciate your time, and I'd like to end by taking any questions.
Microphone in the back, second.
Hey, so Tobias Fiebig, speaking as myself and not an academic. So I was wondering, so if we all just do BCP 184, which is minimally covering ROAS, and we do RPKI, the problem that is measurable by the countermeasures, like by employing the countermeasures, already goes away, doesn't it?
So yes, if everybody does RPKI, but that means that everybody also has to sign and everybody has to ROV. So I agree, in a perfect world, and the ROAs are minimally covering, yes, you would cover it with that, but you would still have to have all those cases. I should mention we have not researched this yet, but there's a chance you could just do this with an equally specific prefix attack, and some traffic that happened to pop up at that ISP would still be rerouted. So I'd prefer to improve visibility. I also think that these countermeasures are much easier to implement than the whole world doing proper RPKI.
Okay, and one quick pet peeve, there is documentation like AS number ranges.
Just closing the queue. The first microphone.
Lutz Donage. I just want to point out that there is a flaw in the common use tool BGPQ. If you're using the plain as it is put as output, it generates RS-pass verification rules which are vulnerable to these attacks because it allows the insert of any intermediate RS. So if you put on a link on downstream or as a downstream to put in such a route, you can simply add the origin RS that RPKI is not invalidated, and you can inject routes, because even if the upstream is applying the filters using BGPQ, it will not detect such attacks.
Thank you.
Lee Howard, IPv4.global by Hilco Streambank. Thank you for doing this work. This is very interesting. Thank you for using IPv6 in your examples. That's wonderful to see. It seems to me, so what you mentioned before, that the equal length prefix would probably also at least capture some traffic. That probably makes sense because the meds or local pref or something will make the decision internally. But I wonder if you know if there's any correlation between transit providers who don't use prefix lists reliably and transit providers who don't do route origin validation. I'm guessing there's a strong correlation.
I think there is a correlation, and I do think there are transit providers that, based on people I work with in threat intelligence, adversaries have different experiences working with different transit providers.
Thank you. It seems to me that there's also another mitigation would be to have better automation for creating ROAs, because if you're using more specific lengths for traffic engineering, then probably just update your ROAs as you need them.
Yeah, I absolutely endorse automatically generated, rapidly updated ROAs to accommodate traffic engineering and DDoS mitigation. That's a major countermeasure here, kind of goes beyond underneath the RPKI point as well. Thank you.
From Roman AX, I would take this hat today. So everybody told everything I had to say before. I just have one more suggestion. Like, if you want to filter or to understand what's happening in your network, Pascal Glob presented a route collection tool in open source, the open source working group this week. That would be really useful, because then you would see that there is like an injection, or someone would be trying to inject a prefix within your routing table easily, because this tool is really efficient for that. Maybe if you didn't see that talk, you should look at the collector, because it's really well done. I think it's a decently good idea to not mitigate, but at least see what's going on.
Oh, thank you. I'll definitely look at that.
Nothing online? All right. Thank you so much.
Thank you.
We'll start the lightning talks now. We'll start with Let's Stop Using DNS by Jen Linkova at Google.
Hello. Now when I hopefully get your undivided attention, I have a confession to make. This is obviously a clickbait title. Well, it's actually correct title, just not complete one. Well, so, yes, I'm obviously going to talk about IPv6 even when I'm talking about DNS. So, how many of you deploy in IPv6 only networks? Good. You need to listen, and people who hasn't, if you haven't raised your hand, you still need to listen, because eventually we will need to deploy v6 only networks, and then my lightning talk will be important. So, if you deploy in v6 only networks, most likely your endpoints need to run CLAT, so all those legacy, poorly written applications which need v4 will be tricked into believing they have IPv4, and then the CLAT customer-side translation will translate everything to IPv6 and send it over the physical interface. So here is what I see on my laptop when I connect to a RIPE network this week, right? Obviously, to do the translation, the client needs to know which NAT64 prefix is being used by the network. So, because when CLAT translates v4 to v6, somewhere in the network there is a NAT64 which will be translating it back to IPv4 and send it to dual stack internet. So as you can see, my laptop successfully gets NAT64 prefix from the network. So traditionally, for the last 11 years, a lot of networks and a lot of clients were using RFC 7050, which allows you to detect NAT64 prefix by using our favorite protocol, DNS, right? DNS can be used for anything, not just for name resolution. You also can use it for detecting NAT64 prefix. How it happens? Your client trying to resolve IPv4 only name and trying to ask for v6 address of that well-known v4 only name, right? So here what's happening on this network, right? Network announce you DNS server. If you ask normal DNS, let's say Google public DNS, you ask for a record for v4 only ARPA, you get an IPv4 address. Special one allocated by Iliana. If you ask for quad A, obviously you get nothing because it's an IPv4 only name, logically, right? Now let's ask DNS server which RIPE's network gives you, which is actually does DNS64. Surprise, surprise, you actually getting quad A record back, and you can double check those last 32 bits are actually v4 addresses in hex format. So now your client can take the prefix from the quad A record and find out which prefix shall be used. Great, right? What could possibly go wrong? First of all, there is I know Jeff told us security doesn't matter, but the problem is you kind of rely on DNS, right? And this thing fundamentally would not work with DNSSEC because DNS64 designed to lie to you. You're asking for something which does not exist. So RFC 7050 has a security consideration section and does talk about security, but it's a very, very hand-wavy. Like, yeah, you need somehow to establish trust channel to your DNS server, somehow. It suggests using some security channel like VPN. So I have not seen anyone doing this. So yeah, so you don't know actually, are you really getting the correct answer? And obviously the problem is if your client is actually on v4 only network, which doesn't have v6 security, and someone tricked you into believing there is a DNS64 and not 64, things could go very, very wrong, right? So there are actually other things which could go wrong. For example, if I take my laptop and try to resolve IPv4 only ARPA and get quad A, I am actually getting nothing. Why? Because my laptop runs its own local resolver. So my laptop completely ignores what networks gives you as a DNS server and run its local stuff. Well, there is an RFC which suggests that local resolver actually needs to look in the network provided resolver for resolving is specifically v4 only ARPA, but again, nobody does that. And obviously, as I say, no DNSSEC, additional RTT, and so on. So a few months ago, some people were thinking, can we solve this, at least this security problem of 7050? And when we started talking about that, we realized that maybe we don't need to solve the problem of RFC 7050 because we have other ways of discovering NAT64 prefix. Again, if you look what this network actually gives you, it gives you NAT64 prefix together with all other configuration for your network stack. Well, if you ask me, obviously it's much better way because I wrote that standard. So I'm definitely biased. But yeah, I like getting everything in one array packet, yes. So now we have competing standards. Great, right? We have multiple ways of doing the same thing. And one of them gives you everything in one packet immediately. And another one does not work with DNSSEC, has security problem, and gives you additional RTT. So what can we do? The obvious solution is let's get rid of 7050. Well, as always with IPv6, we have chicken and egg problem, right? It's really hard to tell people, please don't do 7050, because there are networks which been doing that and not giving you pref64 and router advertisement. And maybe there are clients which do not do pref64 yet. However, the goal of this document is actually can be summarized in 2 sentences, right? If you're doing v6 only network, please, please, please give pref64 to your clients in router advertisements, right? You can keep your DNS64 for legacy clients and so on, but please provide pref64 because it's actually better for clients. Clients can start CLAT much faster without waiting for DNS exchange, right? And it improves security. And if you're writing a client, please rely on pref64 first, even coming in router advertisement, and maybe only use DNS as a backup mechanism. So this will be presented in Dublin next week in DNSOP on Monday. And that's all from me. Clear, right? We all agree.
Any questions?
Online question from Ondrej Kaletka, RIPE NCC. In the RIPE meeting network, we support DOT and DOH with DDR. I think this passes as a secure channel between the client and the resolver.
This is actually how it's all started. Original version of the draft was like, yeah, can we use all those nice shiny mechanisms to improve? The plan was to update 7050 and introduce security mechanisms there. But then there was a lot of line to the microphone saying, yeah, can we just get rid of it? And we're like, yeah, great. Let's just get one way of doing things. Will be much better. So yes, theoretically, yeah, we can look in that direction, but do we really want to? There is a feeling like most people prefer not to. Hello, Gert.
This time I can make it to the microphone queue. Thanks for that work. Thanks for actually showing me what my Mac can do. It was enlightening to actually, after being here for 5 days in the RIPE meeting network and everything just worked, look into it in more detail and see the CLAT operation and so on. Thank you.
My pleasure. Instead of having kittens on the slide, I was going to have pickups on the slide, and then Ondrej actually showed me not much nicer CLI stuff of looking into that. Yes, so.
No more questions? Thanks, Jen, for saving 1 minute of our time. So let's dive into IXP from scratch by Marcel Koch. Marcel.
Hello, everybody. I'm Marcel Koch from DDIX, and I'm going to present you IXP from scratch. IXP from scratch is an article series on RIPE Labs, which we started publishing earlier this year. We are DDIX, an inter-exchange we founded in Dresden last year, and the goals of the series are mostly documenting what we've did with DDIX, gather feedback from the community, encourage others to also build local internet exchanges, and also self-reflect on design choices and actually think about them again. Is it a good idea to do what we've done? A bit of history. There were already past efforts early in the 2000s to build an inter-exchange in Dresden. Sadly, these did not succeed. Last year, we founded ourselves together and started DDIX. It's an association under German law, so it's all voluntary work. Earlier this year, we started our operational setup. We already held multiple open tech meetups. It's basically like a small network operators group where we gather the local community, tell them everything we've done, what is going to happen in the future, and just get together. We already have 3 peers, mostly local ISPs, and also we have multiple 1 gigabits per second traffic peaks. Additional peers are already awaiting cross connects and are building their own infrastructure to start getting connected. What are the reasons we try to build DDIX? This is a screenshot of a trace route we've done before we had DDIX, and we just pinged like a target from one ISP in Dresden to another ISP, and as you can see, we went through the whole of Germany. And also with a latency of like 12 milliseconds, and now with DDIX, we have a latency below 1 millisecond and just stay in Dresden. So also our motto is just keep local traffic local, and it already kind of works. So now to IXP from scratch. We already published 2 articles. First of all, building IXP, what are like things you need to consider. And the second article focuses on the design choices we made. And the third article focuses on the detailed implementation of the peering LAN. We plan to also write articles about our automation and how we are monitoring our traffic and monitoring the IXP itself. If you have another additional topics you want us to cover, please talk to us. Now I want to give you a brief introduction into the second article, network and security design. First of all, an IXP needs some kind of services. First of all, the most important thing, the peering LAN. You also need some IXP management, for example, the peering portal, in our case, IXP manager, and also monitoring stack to ensure the operational of the IXP. Also, because we are the German entity, we have paperwork to do and accounting stuff. We segmented our network in some parts. First of all, of course, the peering part with the peering LAN, our route servers monitoring. Then, of course, we need some kind of management access. For that, we just have an VPN, so we can access our infrastructure remotely. We also have like management infrastructure, for example, file storage and identity management, reverse proxy, stuff like that, and also our hypervisor and the below part. Everything is connected through a firewall and also has like internet access through that. We tried to build the management infrastructure IPv6 only. Sadly, we did not succeed fully, but most of it is actually IPv6 only. Some external APIs that our automation uses and also IXP manager uses do not support IPv6 currently. And also NixOS, the operating system we use for our management infrastructure, heavily relies on GitHub, and GitHub 2 does not support IPv6 currently. So we still have some private IPv4 addresses. On the operating system side, we choose Alpine Linux for our routing, route servers, and firewall. We use it in a diskless mode. That means the whole operating system is in a tempfs. It's like loaded on boot. The disk does not need to be used anymore. It has a really small overhead, and it's just basically just the kernel and the routing daemon, in our case, Bird. For NixOS, it's a declarative operating system. That means you have everything in a configuration file. You can deploy the configuration file. Each deployment generates a generation. At boot, you can select an older generation if you broke something, and it's all version control to Git. So it's also pretty easy to deploy. We also isolate our services because we have like one management host and don't want the applications to interfere with each other. Also because like the automation stuff is like kind of critical. We don't want anyone to be able to inject something in our route servers and peering LAN. And for that, we use MicroVM. It's like a wrapper for NixOS to deploy very lightweight virtual machines using KVM. They are all also disk classed, and we can like share persistent data using a simple mount point with the host system. And also it's pretty well integrated thanks to Astro. If you have any questions, feel free to ask. And also these are like our local ISPs and our great sponsors that helped us very lot with like knowledge and also money. Thank you.
Thank you for that great talk. This first mic up here.
Hi, Steven here from CHIX. I have a question to slide 17. Can you publicly document which ones were also giving problems? Because at one point I'm going to get there as well. So that would be nice to know other caveats, because GitHub is why I have a NAT64 gateway.
Yeah, we are going to do that. Thanks.
Hey, so Tobias Hübich, speaking a bit as like a person who was, well, thankfully in some way involved in what happened to be E6 like 10 years ago by Swayo. I don't know where Swayo is. And you kind of missed one of the most important points of an IXP, which is a community and community building, because this is a technical presentation. I see that the presentation list, like the RIPE Labs article list, it's all about technology. But what, in my opinion, made E6 great was the community building that was done around it. And I would really appreciate to get that more out as well in how you actually start off such a community.
Yeah, like we already did multiple open tech meetups. It's like basically gather everyone who is interested. We got like even operators from the city itself, from like most companies of the city that do networking. And it was really nice evenings. And we also like exchanged technical details.
Florian Hiebler, I just wanted to thank you for actually documenting your effort, because a lot of companies around, communities around the world build exchanges and they keep their knowledge for themselves or share it in closed user groups. I think it is particularly the effort you're making here very, very valuable to a lot of people who are probably not even sitting here in this room. Thank you.
I appreciate that. Thank you.
Thank you again. Our next talk is Observing Trends in Internet Routing Security by Iliana Xygkou from the Georgia Institute of Technology.
Okay. You can hear me? Perfect. So yeah, hello everyone. Today I'm going to present to you some very interesting trends that we have observed in Internet routing security. And this work is a joint work with Professor Cecilia Testart and my PhD advisor, Professor Dainotti. So we'll start this talk with a question for you. What do we really know about routing incidents? And by routing incidents, I mean both actual malicious hijacks, but also misconfiguration mistakes, such as fat fingering a prefix. In both cases, an event can end up causing major financial losses, but also at higher scale, it can impact national security. And unfortunately, about these events, the most knowledge that we have comes from some anecdotal evidence and analysis of very few events that, due to their high scale, they make it to the news. So in order to illuminate the BGP incident space, we have built GRIP. GRIP stands for Global Routing Intelligence Platform, and it is a BGP incidents and detection monitoring system. GRIP has been running at Georgia Tech for the past 4 years, and it is under continuous improvement. So in the following slides, I'm going to present to you some preliminary results that we have obtained by reprocessing all the BGP data from the past 5 years, from 2019 up to 2023. But first, let me give you some high-level background on how GRIP works. So the events that we are targeting, such as those that lead to route misorigination and route hijacking, they generate specific type of events, such as a MOS prefix, a prefix that is announced by more than one ASs, or a sub-MOS one, which is the same but for a pair of prefix and sub-prefix, or even the appearance of a new edge in the AS level topology. So GRIP, using the BGP data from writers and routers, it will detect all of these BGP events, and then to each one of these, it will add informational tags based on additional datasets such as KDS AS rank, and RPKI in order to build a more complete and multifaceted picture of the event. Finally, we have tailored a big set of rules in order, which examine the assigned tags, the assigned informational tags of the event, in order to eventually classify it as a legitimate or as an incident. So let's see what we have found so far by focusing only on the events that lead to route misoriginations, namely MOAS and sub-MOAS events for IPv4. So first, some high-level findings is that GRIP marks most of the BGP events as legitimate, and the remaining 15% is marked as incidents. Most of the incidents exhibit patterns of misconfigurations. These include fat fingering the advertised prefix or the origin AS, as well as the common AS path prepending mistake. But we also see some RPKI-related misconfigurations where even though all the origin ASs are obviously related to each other, not all of them are covered by ROAS in order to be authorized to advertise the prefix. Then only 2% of the events exhibit patterns compatible with attacks, and another 2% might be attacks, but we don't have any clear indications to explain their nature, and that's why we also call them unexplained. So if we look into the data in terms of absolute numbers and at a monthly granularity from 2019 to 2023, we start seeing some very interesting trends. First of all, some very good news is that misconfigurations seem to have been decreasing. And even if we break them down into the different types of misconfigurations, we see that this decrease is actually dominated by the decreasing trend of the prefix fat finger mistake. Nevertheless, we see similar behavior for the other types of misconfigurations as well. For example, the AS path prepending has also been decreasing across the years, except for a spike actually during the pandemic. Okay. 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 So now let's take a look at the other category of events, the events that might be actual attacks. Here, unfortunately, we see that they remain somewhat steady across the years. So, but if we break the attacks into its two components, namely the events that exhibit patterns of attacks with a purple line, and the events that might be attacks, but we don't have any clear indications to hit at the nature, the blue dashed line, we see that the unexplained events have been decreasing over the years, while the attacks, those events labeled as attacks, have been increasing. So we wondered, where does this inversion of trends come from? And we found that it is largely due to RPKI invalids. So indeed, here, with the red line, we visualize the growth in the RPKI ROA deployment. And we speculate that the increase in the RPKI ROA deployment correlates with the inversion of the trends that we saw in the previous slide, because now it allows us to mark an event as clear incident due to the RPKI invalids. So a hypothesis that we validate here is that actually RPKI provides more visibility into PGP events, which is intuitive, but still very good news. And this is all thanks to you and the community who have been pushing for RPKI and who have been publishing ROAS to protect their network spaces. So finally, as GRIP is a system, and we want to keep improving it in order to increase its utility for the community and for all the users. To do that, one very important first step, is validation and feedback from network operators. Because after all, network operators are the only ones who can tell us for sure what happened to their networks, or at least let us know of the nature of the event, whether it was legitimate and intended, or was it a hijack or a misconfiguration. Then GRIP is a very complex system to to operate, and it requires developers and researchers to improve and implement the detection and inference methodologies. And of course, this requires more funding and more human workforce to be able to support the system. And I would like to close this short talk with a more actionable note. It takes a village, including you, the whole community, from network operators to researchers to policymakers, to build a reliable tool that will help us understand what is happening on the internet today, with the ultimate goal of improving its security and ensuring its integrity. And that was all from me. Thank you so much for your attention.
Gerd Döring. Thanks for bringing this tool to my attention. I didn't know about it. I've been playing around it. It's finding interesting things. There's one shortcoming. There's no V6.
That's true, and we are planning to incorporate as soon as possible. The problem with V6 is that, there are different dynamics happening in V6 compared to V4, so, yeah.
There's no V6 to the server, so I have to use IPv4 to do my queries.
Ah, I see. Okay, I don't know.
I didn't check whether there's V6 data. I was just looking at the AS, but there's no V6 transport, and that is easy.
Okay, then. Noted, I will take care of it. Thank you.
Valerie, is there any question? Okay. Thank you, Iliana. So it's nearly the end of the session. Thanks, Valerie, for helping me out in this session. Now I will hand over the mic to Ondrej Filip, the chair of the IPNCC board, executive board, for presenting the result for the GM.
Thank you very much. I think we should wait till 10:30 as announced for the remote participants, so give us a few seconds.
Okay, thank you. That's the end of the session. Thank you, everyone.
It's so simple, the whole thing, that there is nothing happens, and they record it by email. It's more formal.
I remember last time I called it in and everybody started. And you were running on the stage, so I just want to make it happen again.
Thank you for that. But anyway, but it's, this was not a top voting, so I don't think that can be a surprise.
I know. We were just, everyone was, maybe it was everyone who didn't ask Ginabi on Friday. It's just very conscientious.
Everything okay? I'm just waiting. Right. Her name is Xygkou, or how do you spell it? Well, that I distinguish, but I get it wrong. But I don't know.
Which selection of the photos are you able to have? So you have to make sure that that's
I wish I understood those people who think it's games.
You're asking.
I'm so hard to think just don't pay attention to what it says. So there's always some random noise in what makes that you can avoid. Yeah, maybe. Yeah, but I started in 2028. That was the problem. That's why I'm waiting now. On the other hand, come and see. So good morning, everyone. If I can get a little bit of your attention, I have a very simple task just to announce the results of the voting. It was not very dramatical this time. You know, we had just one resolution, and the result is as expected. So the general meeting approved the resolution as proposed by really vast majority of votes. It was 92.6%. So resolution approved, and I think it was very smart decision. Thank you very much for that. I have one more thank you to Carla Skarda from APNIC, who was the independent observer of the general meeting results. Thank you very much for that, Carla. I thank you all who participated, and see you next time. Thank you.
deviating directly. So, yeah. Sorry? Yeah. So I'll kick off and then, yeah, go from there. Well, if you want to, that's also fine. Speakers have their things with a brief time. Sure.
Hello, everyone. So we're ready to start the last session of this meeting. And as first talk, we have something about zombies, which is in line with what you had last night. And here we have Antonio's Chariton and Iliana, Xygkou. Did I pronounce it correctly? Yes, which will talk about reviving BGP zombies. So big applause for them.
We're going to talk about BGP zombies, as Max said. This is, to be clear, this is the internship work that Iliana did over the summer while we were lucky to host her at Cisco Thousand Eyes. Before we begin, let's see what are BGP zombies, or stuck routes, as some people call them, or ghost routes, as they were being called many years ago. So in BGP, let's say you have a few autonomous systems, and they are connected somehow to each other. And if you have a prefix, and you need everyone else to learn about that, so they can send traffic to you, then you generate what's called an update message that is an announcement specifically, and it contains the prefix information. And to this message, you then send it to all of the connections that you have with the appropriate relationship, and then they send it to their peers, and eventually the entire internet knows about your prefix, and they can send traffic to you. If a link is down, or if a prefix is unavailable, then you generate another type of update message, which is called a withdrawal. In this case, it's the similar thing. So everyone that you send the announcement to, you have to send the withdrawal to them as well. The problem is that in some cases, these messages may be lost. It may be network issues, it may be software issues on either side, but for whatever reason, these messages could be lost. And right now, we end up with a routing inconsistency. So the first two ASs correctly say that this prefix does not exist, but the third AS thinks that this prefix is still there. And obviously, this routing state is inconsistent. And if the third AS has downstream customers, then they're going to not inform them about the withdrawal either, because they never learned about it. So every customer downstream of that AS is going to be infected. So why is this a problem? Well, there are several reasons. Of course, the most important is that a router's job is to route packets correctly, and it can't if there are routes stuck there. The other thing is that there are paths that may be active that you don't know about. And for example, if you have a DDoS attack and you do some DDoS mitigation, you send your traffic through a provider or through a different link, and then the attack is over, you switch it back to the original path. However, traffic gets stuck and is still sent through this route. And if you have, for example, if you pay by the hour on your mitigation solution, you're still getting charged for all of this mitigation that's not actually happening. Then, of course, you may have incorrect alerts that you may be getting. So you may have a very noisy alert system, and eventually the number of routes in the internet will keep going up if this happens. And finally, you know, for those people still using IPv4, if you sell it, you know, a small percentage of the traffic may not arrive at the new owner, it may still come to you. So BGP zombies are a problem if your routers have someone else's prefixes stuck there, or if your prefixes are stuck in someone else's routers. Both of these are bad for your network. And by the way, we saw that it can happen with withdrawals, where you think a path exists that it doesn't. However, it can just as likely happen with announcements, which means that some path will never be used. These are much more difficult to study. However, it's something that could happen as well. But you have so many problems as operators. So we wanted to see if it's a big problem, like if it's something that you should care about, or if it's just something that you can ignore. And in order to do that, Iliana is going to tell us that actually.
Okay, hello everyone. In order to answer these questions, we first looked at the existing literature. And the first paper to look into BGP zombies was published in PAM 2019, and it studied stack routes involving RIPRIS beacons. So RIPRIS beacons are specific IPv4 and IPv6 prefixes that are announced and withdrawn periodically by the RIPRIS collectors to their peers. Starting at midnight, the collectors will announce the beacons every 4 hours, and they will withdraw the beacons 2 hours after its announcement. And thus the reachability of the beacons can be visualized as a pulse train, as we see here. So when it comes to detecting BGP zombies, the most important parameter to define is after how long since the prefix's withdrawal should we consider a remaining route as stuck or zombie. And the authors picked a conservative threshold of 90 minutes in order to ensure that they wouldn't falsely report as zombies any delayed withdrawals. So the authors executed the experiments over 3 different time periods of around 1.5 to 2 months each. And actually here in the results table of the paper, we fix a typo in the second line to prevent any confusions around the duration of the experiments. So the authors found that in just 5.5 months, there were more than 5,100 zombie outbreaks, which is very impressive. And that's why we wanted to repeat this work in order to validate the results, and we want to repeat it using the raw BGP data provided by RIPRIS. And surprisingly, when we did that, we actually found 640 more zombie outbreaks than the papers, and an increase of about 13%. So where could these discrepancies be coming from? Actually, our methodology was using different tools than the papers one. We were using historical BGP data provided by RIPRIS in order to be able to reconstruct a peer strip at any time point. On the other hand, the authors were using the RIPRIS looking glass in order to detect BGP zombies in real time, and then they later filtered out any false positives by using the RIPRIS raw data. So having seen these discrepancies, we wanted to, we were motivated to further improve the detection methodology in order to be able to more accurately tell apart a zombie outbreak, as we see here, from a complete and successful withdrawal. And actually, the RIPRIS collectors marked the BGP announcements of the beacons with some very valuable information. More specifically, they populate the BGP attribute aggregator IP address with this value, where the last 24 bits represent the number of seconds that have passed since the beginning of the month until the time of the announcement. And this allows us to uniquely identify beacon announcements within the same month. And how can this be useful? It actually let us avoid double counting all zombies. For example, if a prefix announced at 12 a.m. gets stuck in a router, and it remains there even after the new announcement at 4 a.m. and the new withdrawal at 6 a.m., we shouldn't count this remaining route as a zombie twice, but only once for the time interval in which it was originally announced. And indeed, when we applied this additional filter, we found a significant reduction in the total number of zombie outbreaks, a reduction of around 33%. And also, we furthermore revisited some of the results that the paper was also doing, and we found that 1/5 of the pairs, Riper Spear and Beacon prefix, were not affected by BGP zombies at all. And such a pair would exhibit the probability of around 1.6% for IPv6 and 0.5% for IPv4 to present a zombie. Finally, as expected, over 90% of the time, the ACE path of the stack route was not the optimal one chosen initially by the BGP selection algorithm, but instead it was the one that it emerged during the path hunting process after the prefix's withdrawal. So having revisited this previous study and having improved the detection methodology, we came up with some new questions that will help us understand the zombies topic more extensively. One such question is, how long can a zombie survive? Is it just a couple of hours, or can it go up to days or even weeks? Another question is, how does a zombie's visibility change over time? But answering these questions requires that the prefix of the stack route is not announced again very soon, because then the new announcement is going to wipe out the stack route. So, and we're going to lose this information. And unfortunately, the Riper's beacons provide us with a short interval of 2 hours between two announcements of the same prefix. So in order to address this issue, we came up with, we implemented our own BGP beacons methodology, which we called BGP clock. And that is because in the prefix itself, we included the hour and the minute of the time of the announcement. So we would advertise a prefix every 15 minutes, and we would withdraw it 15 minutes later, resulting in 96 different prefixes per day. Of course, these prefixes, as you can see, they would be recycled every 24 hours. So after running the experiments for several days, we modified the prefix to also include the day, the day of the announcement. And in this way, the prefix would now be recycled typically every 2 weeks. And this would allow us to study the lifetime of a zombie route more extensively. Of course, following security best practices, we created our own ROA on the RIPE portal for the covering prefix /32 in order for our announcements to be marked as RPKI valid, and in order for them to be able to propagate fully into the internet. So in our BGP clock, the announcements were made by Antoni's personal AES 210.312, a highly interconnected AES with more than 1,700 neighbors. And this suggested that the announcements would fully propagate to the internet very rapidly. In general, the notion behind implementing our own BGP beacon methodology was that with more prefixes that could potentially survive as zombie routes for an extended time period, more than just 2 hours, we would achieve more diversity and less noise about which prefixes get stuck. And also, we would be in the position of studying how the visibility of zombie route changes over time. And indeed, we found some very interesting cases of some quite stubborn and impactful zombie outbreaks. So this one was found stuck in the routers of 6 Cypress peers, even 3 hours after the prefix's withdrawal. And using the AES path of the stack routes, we found that the probable cause for this zombie outbreak, it was actually a French AES, FreePro SAS, with more than 200 AESs in its customer cone. We hypothesized that probably all of these AES in the cone could have been infected, but we can be certain only about 6 of them which are connected to the RIPRIS collectors. And in this slide here, we visualize the zombie outbreak by using the AES paths of the stack routes. So in order to create the zombies AES graph. And in the red square here, we highlight the AES that we assume was the cause of this problem. And how we determine this is that our AES graph starts as a single chain with the origin AES as the root. And then, at the red square, it branches out to multiple subtrees whose leaves are the RIPRIS peers. So, if, for example, an AES before the annotated one, let's say this one, was causing the stack route, then its own upstreams, its own downstreams would have also been infected, and we would see the stack routes in them as well. So this branching here would have occurred earlier at this AES. Similarly, if an AES after the annotated one, let's say this one, was causing the problem, then this would mean that all the AESs at this level somehow missed the withdrawal of the same prefix and at the same time. But we need to clarify, we're not here to point fingers to AESs. This zombie outbreak is not necessarily a problem caused by the annotated AES. It could be that the previous one failed to propagate the withdrawal message to them. Our goal here is to be able to understand where the problem could be coming from in order to facilitate its resolution. Then we have some 2 additional larger zombie outbreak cases. The first one seems to have come from a large German AES belonging to Core Backbone GmbH, with more than 2,000 customer AESs. And naturally, we saw more RIPRIS peers having this stack route as well, namely 21. And actually, even Ben Cox, in their own analysis of BGP zombies, they have observed this AES to be having stack routes. Finally, we observed that another German AES, Mylock, with a few hundred AESs in its customer cone, might have caused a very quite persistent and very long-lived zombie outbreak. And now, I will let Antonis continue with some additional interesting findings.
Thank you. So we were done with this research. It lasted about a month, and we didn't want to have it running. This generates a lot of BGP updates. We wanted to be careful with your equipment. We wanted to do responsible research. So we stopped all of the advertisements, and we deleted the ROA from the LIR portal. And then something interesting happened. because that night I got an email from RIPE. And for those that cannot read it, this is an email that you get if you have RPKI invalids. And it says, you know, if this is intentional, go issue new ROAS. But if it's not, then perhaps you need to look into that. There's maybe a hijacking or something. And I keep getting this email every night, 3.5 months later, which, you know, it's very interesting. So the routes are still stuck. I'm happy to report that zombies are still there. It's been over 4 months. And, well, the RIPE risk cleared recently. So there goes that. The email will stop soon. BGP tools still has 3 of them in there. They're still stuck. And Hurricane Electric's BGP toolkit had 4. We're now down to 2. I'm happy to report that we have a half-life of a few months for BGP zombies. And these prefixes have been invalid for months here. So if you want to test, you know, RPKI adoption and those pesky internet exchanges and these transit providers, they do filtering and they don't let you test the other ASs. What you do is you can just get a route stuck somewhere and then turn it into invalid. And now you can see who keeps it and who doesn't. So an interesting point about RPKI research. So what did we learn from all of that? Well, the first thing is that zombies drop over time. And here you can see on the x-axis, you can see the time. This is like almost at the 3-hour mark. You can see, you know, they start going down, but however, they start to plateau after a little bit. This is a special zombie case that we had. Now you want to look at the orange line. And the thing is, we found 2 ASs that are RIS peers, where almost 10% of the time the routes were getting stuck there. So we had so many routes that created problems for measurements, where the orange line is if we exclude them. Something else to point out is that at some point, the zombies start going up. What's up? Like, we wanted to explore that a little bit further. And it turns out that around 3 hours, we had a new announcement. We looked into the data and someone created an announcement for a route that was withdrawn. And we identified that this happened in Telstra Global. So something, you know, a link went up again, config changes. We don't know what caused it, but something caused, you know, a full table probably to be sent. And this full table included the stuck route. So the interesting thing here is that these zombies can, you know, reinfect hosts. Like a lot of their downstreams had successfully removed the route, but, you know, something changed and they got the route again. So it's really easy for these zombies to stay forever, especially if there's some kind of reinfection being triggered by, you know, normal operator things. So can we do something about all of that? Because that's eventually the question. And thankfully, the answer is yes. There is a draft in the IETF. It's practically an RFC, I would say, which creates a second timer for BGP sessions. It's called the send hold timer. And what this does is that basically, if you cannot exchange data with high certainty with a peer for 20 minutes, you take the session down. And you do this to protect your network and all of your downstreams. And we think, like, we don't know yet, but estimates are this is going to solve 30 to maybe in some cases even 40% of the stuck routes. It's not going to solve everything, but it's going to do something. However, for that to happen, we know that vendors have to add support. There's a BIRD, OpenBGPD, and FRR that have added support. No hardware vendor has done it yet, so you can be the first if you're in this room. You know, that spot is still available for anyone who wishes to claim it. And if you're not from a vendor, but you buy equipment from a vendor, you can ask them to implement it, because then it has to make it to the stable releases, and then all of you here in this room have to update your routers, and it's going to take some time. It's not something that will be done by the end of the year, probably. Maybe the decade, if we're lucky. Yeah, but maybe that's optimistic. Yeah. So we think that this is a very good path forward, and please ask that from your vendors. It's going to be great to have that, and ideally ask them to have it on by default. That's going to be awesome. And with that, we have 3 blog posts that you can download the PDF and click on these individual icons to read more about. And I think that's it. One last note I may add. The research here was done with a personal AS, as you've seen, so they're actually useful. So, thank you.
Okay, I think end of the decade is, I mean, yeah, optimistic. Hardware vendors always put these things in so quickly. Okay, wow, we're gonna, that's a full queue there, I think, at this point in time. We're gonna start on with Jen, and then we'll go through.
Hi, Jen Linkova. First of all, you're very cool. Thank you very much. One clarifying question and one real question. So I'm seeing Cisco Confidential on the slide. Shall I be concerned?
I hope you weren't paying attention to the slides all this time. It's too late now, I guess.
Yes.
Yeah, the material leaked.
So
Sorry.
we're going to sign an NDA in a bar, right?
Yes,
Okay.
please.
Good. Sorry, I missed the very beginning, so I'm curious. So you're saying that it's normally caused by the fact that the peer cannot reliably send announcements, right, to the other side, right?
Yeah.
I'm wondering, first of all, what's happened to the traffic in this case, really?
Hmm.
And secondly, have you actually talked to those people to find out if it's a bug in event, particular implementations? Practically, what does it mean? Do we have a like issue with particular vendor, particular software version? Could it be fixed by as a bug fix?
Yeah. Do you want to take this? Okay. So we have identified some vendors that where this happens way more than others. And we are in the process of notifying them internally and externally. So yeah, eventually we want to get in a position where this doesn't happen. It's almost always bugs, like, you know, the TCP window is 0 only in the BGP session. So data still works, or, you know, there's some state corruption in one of the peers. Like, it's so many cases that we think are there. Yeah.
I think it's interesting that people really notice the Cisco confidential bit and have not made any comments about all the other internal confidential only things that have been on the slides this week.
Yeah.
Something about very popular names.
We're clearly the most popular.
I mean,
Yeah.
clearly, yeah. It's just, and then all the Juniper people come into the room. No, please.
Alexander Azimov, younger. Thank you very much for your report. I have one question, one comment. Okay, let's see. So first of all, I would love to know if you tried to talk to RIPE risk guys to ask them to change the way the beacons is generated on their side, so it will be look like what you did, because I find it quite useful.
Mm-hmm.
No, actually, we did not reach out for this modification. We wanted something to happen very quick, like an internship plus very short, right? So we also were in the position where Adonis had his own personal AS. We had a large IPv6 prefix, so it was easier for us in terms of time to do that.
I would love to see collaboration between you and RIPE so
Of course.
in future, so that this research will not be just one-time research, one-time measurement, but it will be continuous measurement for all of us.
Yeah. And if I may add something, sorry, before you move on. We want to do this again with V4 as well, because that's still being used in a few places. And I tried to expense this last 8, but my corporate card did not work. But we're trying to figure out a solution for that as well. So we may set up, something long-term as well, probably.
Okay, okay. I know some company, not commercial, that still have some address space. But okay, the second question is, have you tried to, so you made a measurement and you see that there are stuck routes in some of the peers that are from right views or from right trees. Is it possible to isolate them? So to make a list of the peers that give you stuck routes, because of course they affect measurements if we are trying to use these data.
If we can provide like publicly a list of these peers that appear to have this.
My question, is it possible, first?
Yeah, I think, yeah, it should be yes.
I mean, it's technically possible, let me add here, as the still employed person.
So just to be sure.
Okay, we do need to move on. We have a lot of people.
Okay, so thank you very much. Thank you.
You're welcome.
And yes, to be clear, the queues are cut at this point in time. Peter.
Peter Hessler from Zayo Europe. As a network operator, how can we detect that there are stuck zombie routes within our network without doing such a large-scale experiment? How can we identify, and especially identify zombie routes that are stuck that are not part of such an experiment?
Buy Cisco products. No. No. So the difficult thing here is that you don't know the ground truth. So if you monitor your routing tables, you can be certain whether this is intentional, like someone sent something only to you, or if this is something that happens at scale. So I think the best approach is to have these kinds of monitors that collect data. Maybe you can have private BGP feeds that augment that, and you can figure out where the stuck routes happen. But we will need to productionize that. I don't think it's difficult to do a community project, maybe. That would be awesome.
Okay, thank you.
Please.
Sylvan here from Open Factory. I have checked my ticket system. You have never requested a session with us, but you actually have an IXP port. That was interesting. I'm wondering here, are you reaching out to those operators actively? That's one thing. And the second thing is, I sometimes do get people who end up with me blaming me for stuck routes, and every single time it's actually not in my network but somewhere else. It seems to be quite hard to troubleshoot such routes, so it would also be appreciated to have more like troubleshooting material.
Yeah,
we can point people to.
Yeah, our goal is to do that. We have not reached out to all of the networks. We want to do V4 first, so our list grows a lot, and then do that.
Please.
Ondrej Zajíček, Beer Developer. I would have two notes or suggestions. First, would you consider randomize the periodic announcements instead of doing it strictly periodic? Because the strict periodic could interfere with something like periodic reconfiguration in the internet exchange point. So if you do randomize it, then you could have better sampling. And second point, I think that there is perhaps case for BGP speakers to do periodic enhanced route refresh.
Great, thank you.
Gordon Gidolfavi, unaffiliated. You mentioned that you shut down the IPv6 experiment and after you collected the data, and that you might start up a V4 experiment. Do you perhaps plan on continuing the IPv6 experiment, perhaps not as a measurement, but as sort of like a service for troubleshooting these stuck routes? Probably, like it could be caused by vendor bugs and such. I feel like that the route churn it causes does less harm than good.
Yeah, so we want to do them both, and we'll try to keep both. I cannot promise you anything about V4 because all of these V4 addresses are personal. So I may have other commitments for research or otherwise, but maybe we can get some sponsorship from our lovely brokers outside, where we can leave the V4 on as well. But V6 will probably stay.
Thank you.
Please.
Maria,
another bird developer. I'd like to first say thanks to Ben Cox and Job Snyders, who were actively pushing this RFC, even to the extent that they approached me at a NANOC meeting saying, "Hello, have you already heard about our Lord and Savior BGP send-hold timer?" So I basically had to go and implement it. The other thing is we had to test it against something. So there is inside Bird, there is also an option which was originally called break the receiver side as a Xygkou does.
I wouldn't know anything about that.
But
yeah.
For now, it's neutral, and you can use it if anybody wants to. If anybody wants to implement it, you can use it against Bird with this option to actually test that it actually gets killed.
Yeah. Thank you. First of all, yes, I use Bird as well, so I will try to turn it on in every session soon. And the other thing is, yes, like Ben did some great work to promote this, and we're here to further that work by telling you all about it. And remember to request it from hardware vendors, present company included.
Okay, thank you very much.
Thank you.
Okay, so that is our last presentation, but now we move on to the what's been happening this week section of the closing plenary session. So I think, Rob, you are hopefully somewhere in the room to give the Code of Conduct update. Or somebody else from the team gets to give it. Francisca stood up first, so no, it's you, Francisca. You win a major prize. So this is, yes, Rob will have his internal performance hearing from the Code of Conduct. Anyway, Francisca, please.
An easy one. Is it not? Yes. Okay, so short chain of plans. Welcome to our transparency report. Update from RIPE 88. What have we done so far? It's sad, I can't see it here. We have reported, between then we got 2 open cases. We had team members who needed to recurse because there was a conflict of interest. We take contact with the reporting party, and that all went well. We concluded 1 incident. Indeed, it was a violation of the Code of Conduct. We did apply consequences, and in between, we did another ongoing report. So, let me see, where are we? Right, we got additional reports via email. So this means we usually sit down, we form assessment groups. Those were loosely related to what happened at the last meeting. So this is technically not RIPE 88, but it was related, so we count it as this. We recused some team members because there was also a prior conflict of interest situation. We went in contact with both parties, we concluded it. We had 1 incident that was a potentially violation of the Code of Conduct. The subject of the report agreed to our actions, and we could conclude this to our satisfaction. And again, we have 1 ongoing report, so we can't comment on that. And now to the absolutely delightful news. No report for this meeting, so everyone has been behaving at their best, and this is how we like it. Again, everyone who was at the community plenary knows that we are still discussing to change some details of our processes and how we report, how we handle and deal with reports. Here's a quick reminder. How do you report? You can report to any of us. You can report via email to the Code of Conduct form. It will go to all of us. We are approachable individually. We are around here. We try to be clearly marked and visible. And if you wonder whether something you experience is worth reporting, come and report it. If we figure out it wasn't anything, we will figure it out and it's all gonna be fine. But we have a nice short link, right.net/COC, so you can look everything up there. We still are happy to take new people on the team because, as I already pointed out in the community plenary, we try to load share, we work in different time zones, different perspectives. This is all very good if we have more people. And on that more rather sad note is Vesna is leaving us. She is stepping down. She has done a lot of long work in the entire team. Those who remember still the trusted contacts, she was already on that, and that brought an insane amount of experience to our team. But it's time for her to step down because also we have term limits, and she decided this is time for her right now. And that doesn't mean that she steps down out of our community or the general topic of interest, but this is what it is, and I would like to thank her very, very much for all she did for us. This one even has a question slide. So.
Hey, Dmitry, speaking of myself, just a quick comment. We have a lanyard code for staff black. Maybe you need a lanyard code for the code of conduct members, although the faces are displayed in this little poster, so maybe that's enough.
You mean the QR code with an email address? Oh, the lanyard, yeah.
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 The one you wear. Okay, you wear a gold one. Well, me too.
No, we actually in the
I don't know if
past,
it's a good idea.
we had buttons, but they turned out to be a little bit small, and we have it on the badge actually this time. We got upgraded, but yes, I agree. We should be super visible, and yeah, it's something we were working on.
Maybe things on the bottom. You know, I've seen it at
we
Nanode
will
when you
figure
put
it
these
out.
things under. Yeah, something. You know. Okay.
Yeah, I hear you.
Hi, Tina Morris, AWS. Dealing with this in other communities, I'm starting to see, while we want to keep everything as anonymous as possible, protect both parties, all of that. For the community, it'd probably be nice to have very generalized categories of what the issues are, and maybe aggregated by year or something to distract from, so we still keep the anonymity appropriately. But so we can see where we need to improve, or if we are improving, you know, we used to have this kind of complaint, and now we don't see it anymore, that kind of thing.
Thank you. Actually, yes, this is also a call to us being actually consistent in what we do, because in the past, in the transparency reports, we actually did that. We broadly categorized into cultural misunderstanding, not taking care of others' feelings. What I can actually really proudly say about this community, to the best of my knowledge, until now, we haven't received any harassment, sexual harassment related report, which is something that makes me personally really happy to be in this community. But yes, we should definitely do that again. Thank you, Tina.
Good. I don't see any other questions. Do we have anything online? Brian? No, nothing online. So thank you, Franziska. So now we have Rob, which I see running towards the stage, Rob the Meester. He will give us the technical report, the presentation we've all been waiting for, right? No pressure.
Good morning, everyone. My name is Rob, and I indeed would like to present you with the RIPE 89 technical report. The last time we were here was RIPE 60, and things were quite different back then. It was long before I worked for the RIPE NCC, but I had a look at the technical report in the archives, and only 6% of the traffic on the meeting network was IPv6. And I guess it was much colder back then because the tech team equipped some of the chairs with complimentary seat warmers. But I was happy to also see some faces. For example, on this slide where they introduced that the meeting would be streamed in Flash for the first time. So this is us, the technical team. We are mostly responsible for, like as the name says, the technical aspects of the meeting. Unfortunately, Noella and Alexandra were not with us, but they were supporting us remotely from Amsterdam. And this meeting could not have happened without them. Before the meeting, we take about 3 days to set everything up. And then after this session, we pack everything up in 3 hours. And this is a small selection of all the stuff that we bring. So our equipment arrived in Prague on Wednesday afternoon already. And we received this email from the hotel that one of the flight cases fell out of the truck during the offloading. And I quickly checked the contents, and it turns out there was some fairly crucial equipment for this meeting in there. So for 2 days, we were in this like Schrodinger's flight case situation where it was either completely fine or everything was all broken. But luckily, it turned out everything was undamaged. And to be fair, this probably isn't the first time it happened. It was the first time we were told about it, though. So props for the hotel for being honest. This is our meeting network. This is the logical topology. All routers that we have run are virtualized onto small supermicro servers running VMware ESX8. And for this meeting, SESNet kindly provided us with connectivity. So one of the cool things about our job is that every location we visit comes with its own special challenges. So for example, in this case, all these sockets in the hotel had already been patched. All the fibers had been utilized. The hotel IT company inherited their entire infrastructure from a vendor, a previous vendor, which had left no documentation for them. The patch numbers did not match the patch numbers at the walls, did not match the patch numbers in the cabinets. But luckily they had all LLDP or CDP visible, so that made it at least a bit easier to identify the correct ports. There's a 1 gigabit connection for everything the hotel does, which also includes hosting the internet for the entire shopping mall that is adjacent to here. And because that was likely going to be problematic for us, SESNet then arranged a dark fiber for us to use. So if you experienced any issues ordering your double Whopper, it wasn't us. We requested to use the hotel switches for the network, but it was rejected. So instead, they freed up some fiber pairs for us and marked cables, which worked. They also allowed us to place some equipment in their server rooms. For example, here you see our 2 core switches and the 2 hypervisors. They host about 25 VMs, mostly deployed with Ansible. And thanks to the hotel, we were also able to address one of the most heard complaints from Right 88. I'm not sure if anyone remembers, but I'm happy to report we finally achieved proper connectivity in the restrooms. Well, actually, I heard connectivity over there is pretty decent this meeting, but I really want to stress it's a happy coincidence. It's not a new standard. For the meeting network, we like to use as much open source technology as possible. This is some examples of the stuff that we use. During RIPE 88, we encountered some problems with all our edge routers that run Oracle Linux 9. They did not like receiving a full BGP feed, which resulted in very high CPU usage. And after the meeting, Robert Scheck got in touch with us, and he told us he saw a similar issue in their own environment, and he had reported it to Red Hat as a paying customer, and therefore it got fixed, and now the fix is available for everyone, including us. So thank you, Robert. And then when we were setting up, we had an interesting incident with our connectivity. It worked, but every now and then the BGP session went down. And it turned out SESNet did not propagate our prefixes to the rest of the internet, which caused our DNS resolvers just to not work. Bird is configured to connect to the RPKI validator using a DNS name. It got stuck for 24 seconds trying to resolve the domain name, and this was enough for the remote router to consider iSight dead. We reported it to the Bird developers, and their answer was just don't use DNS or upgrade to Bird 3, which is multi-threaded, but I think also still in alpha. So just like last meetings, we had 3 separate networks this time. The main network is IPv6 mostly, and if you want to learn more about that, Jen did a very good talk in the IPv6 working group session last meeting at RIPE 88, so I really recommend checking that out in the archives. We still see a decline in the usage of the legacy network, which is a very good trend, and we're still really interested to hear your reasons for why you would still be using the legacy network. One of the main reason that we know about, that we've seen happen this week, is because IPv6 mostly and VPN clients do not play nicely with each other. It's often related to a feature that vendors call IPv6 bypass. So basically they disable IPv6 as soon as the VPN is set up to prevent any data from leaking through it. But unfortunately on an IPv6 only network, as soon as you turn off IPv6, there is no connectivity anymore. So we behave this, for example, with Proton, Tunnelblick, Cisco, but there's probably a lot of clients out there with similar issues. We've presented on this before, but our presentation system mostly remained the same for past meetings. So in each room we have 2 Mac Minis connected to a matrix switcher, and we prepare everything at the tech desk for the next presentation in the back, and at the right moment we switch to preset. And that setup just works really well for us. But then everything went black. Once in a while, the projector just completely went black, and for 4 seconds, which doesn't sound like a lot, but when you're standing up here or sitting at the tech desk, it feels like an eternity. We tried replacing every component that this could possibly be related to, but eventually we traced it down to something in the beamers. So the AV company tried a lot of things to fix it, and eventually they did. So in the drawing, our setup looks like this. The only difference from last meeting are 2 HDMI audio splitters, and there is a bit of a story behind this, because some of you might remember this scene from the last general meeting, where we tried playing a pre-recorded video and it froze multiple times at really awkward moments. It was because of a driver issue with a super old USB sound card, and we were unable to fix it live. So in the end, my colleague Sjoerd walked up stage, played the video from his laptop, and bended the microphone to his speaker so the sound would be audible in the room. And to be honest, this moment has been haunting me in my dreams ever since. So to fix this, we added HDMI audio de-embedders to the chain, and we got rid of those sound cards completely. And we got to test it already on day 1. Jeff Houston did a presentation with a pre-recorded video, and it worked really well. So since Monday, I slept like a baby. Some statistics. So the percentage of devices operating on dual stack has remained quite stable, as you can see in this graph. It's likely due to the adoption of option 108, also known as the IPv6 only preferred option, which is supported right now, I think, by Apple and Android devices. Microsoft has announced plans to support it somewhere in the future, and there's a potential for Network Manager to hopefully implement it down the line. So once these systems also fully integrate option 108, we expect that dual stack usages will reduce to only a very small fraction of devices. This is our map of access points on this floor. The green ones do 5 gigahertz, the red ones also do 2.4, and the pink ones are actually in the patch room above this floor, but they're set to low strength so they don't interfere with the actual meeting network. There's a special AP that I want to point out, which is AP78, which is near the foyer area here, because this is a snapshot from the device associations per access point during the social on Monday, which happened in the foyer area here. And the top 3 access points here are all in the foyer, but unsurprisingly, AP78, the yellow line here, is the one closest to the open bar. I'll let you draw your own conclusions here. As usual, when there's a barista, we try and ask them to keep track of some statistics on how many espresso they make. This was the first meeting where we had a redundant barista setup, and it turns it turns out this resulted in a record number of coffee consumed, with an average number of 1,362 shots of espresso pulled per day, which is impressive. And concluding, I would like to give a big shout out to Miteco. 2 of them are here, Alessandro and Antonio. They're with us in Prague. They make all the remote participation work run very smoothly. There's the brilliant stenographers again, which have been amazing again this meeting. And then lastly, thank you Cessnet for providing us with the great connectivity here, and our host CZNIC, especially Daniel, who walked us around Prague for days to look at social venues. Thank you. So lastly, I would like to encourage everyone, please get in touch with us if you have any ideas, feedback. We're always looking for new cool things to implement, experiments to run. Please email us or let us know. We can discuss it. I'm happy to take any questions if there's time.
So I'll be putting in a GDPR erasure notice for my MAC address and the AP near the bar from Monday night. I'm increasingly worried about the NCC surveillance state that is building up here.
You're all completely anonymous here.
Sure. Please.
Hi, Sylvan from Open Factory. I have one question. What is this cable going to the toilet in your picture? Is this the uplink?
Can I not comment on this?
Garbage in, garbage out. Please.
Urban Sredolnik, speaking for myself. Can you go back to the VPN slide?
Yes. Sure.
On the IPv6 mostly.
If the clicker would work.
So the, I think is,
this is,
yes. So this is a problem that's been ongoing for a while. I think it's reported, it's not on you, but like it's reported for 5 RIPE meetings now.
Yeah.
So I think it was like there's presence of some of the vendors here and been reported. So I think it's time for like we did the cookie, now it's time for the stick. Can people start reporting this to vendors? So everybody that has problems with us, and also some people that are here from the vendors said maybe some external pressure is needed. So can everybody that has problems open tech cases on the VPN problems on IPv6 mostly networks?
Yeah, good idea. Thanks.
Is this higher or lower priority than the zombies? This is the big question. No, please.
Oh, okay. Again. Well, the reason we use the legacy network, the reason I used it, because it's reachable in lunch area, and I don't want my phone to switch.
Right.
I didn't see any photo, of the lower, and I like it that you gave the word sinkholing a new meaning. Thanks.
Yeah, okay, thanks.
Linkova. Yes, thank you for mentioning this. We need to talk because I think we might want to mention this in deployment consideration document for this. I'm sorry if I missed it, but you put such a nice historical graph on your first slide, but what's the statistic for this one, for uplink data?
We have it. We can share it, but the presentation had too many slides already, so I'll share it afterwards. Thank you for pointing that out.
Or you can wait till Lisbon when it will be included in the historical graph.
Blake with Zeo Europe. Thanks for putting this together as always. It would be super cool if like a sanitized version of the IPv6 mostly edge config could be published on the RIPE GitHub page so people can take a look at it and see how that works. That would be super cool.
That's a good idea. Thanks. Well, we'll consider that. Thank you.
Okay, I think we continue to all be in awe of what you and the team all put together. Yeah, okay. Yes.
It's a question on the chat from Ruben van Staveren. I think Fiber was asking as a private internet citizen. Would you consider replacing VMware with something else, given the current affairs with its vendor?
Yeah, I think we'll consider that. Yeah, it's maybe not for next meeting, but we're keeping an eye on the situation, and we're considering that. Yeah.
Anything else? No? Cool. Yes. So we do continue to be in awe of what you and the team put together for 1 week for all of us. So thank you all, to you and all of the team very much.
Thank you.
So thus concludes the PC part of all of this, and we will hand over to the RIPE chair. So Mirjam, please.
Thank you. Thanks again to the tech team also. This is amazing, and we couldn't have this meeting without a good network here, of course. My slides are there. Right, so this concludes the, there we go, RIPE 89. A very well attended meeting. We had like over 650 people here online, and on site was 750 in total, both online and on site, from 60 countries. So I always find amazing, how many people are from, all over the place are meeting together here for the RIPE meeting week. It's fantastic. Just a few words about the local hubs. We had 3 local hubs. They were following us. I saw some of them in some of the sessions participate, and the one in Romania sent us this picture, and they had great fun there together. And so if you're interested in setting up something like this, the RIPE NCC happily facilitates that and helps you. And there is a link. There will be a link on our website for RIPE 90 as well. Now, coming to some changes in roles and community roles, if you will. So the first one, I'd like to announce the results of the NRO-NC elections. Ondrej Robaczewski will be the next person on the NRO-NC. Yeah, big applause, Ondrej. I don't know if you're here. Do you want to say a few words?
Yeah, maybe a few words. Thank you very much. For your trust. Really touched me. I think I can express my gratitude enough to people that publicly express support. Constance, Konstantinos, Kriti, thank you very much. And for all of you who voted for me, I really appreciate that. And through the week, many people talked to me and encouraged me and supported me my nomination. So I think even if I wasn't elected, it was worth the torture that I had creating this selfie video of myself. But now I have this kind of pressure on my shoulders, and I'll do my best not to let you down. Thank you. Thank you very much.
Yeah, thanks. There will be a lot of work on your plate and on the plate of the other team members on the NRO-NC, and also thanks to the other candidates who stood for this important role. Moving on, yeah, we already heard from the Code of Conduct team here again are the faces of that team, very important role. And I would like to give again a special shout out to Vesna. Vesna, where are you? Come up here. I have a gift for you. Wow, amazing, yeah.
Yeah, Vesna and I started as trusted contacts actually at Vibe 77 before we had a code of conduct team in place, and then moved over, transitioning to the code of conduct team, helped the new members there. And I'm really pleased to see so many community members now on the team. And yeah, I'd like to thank Vesna again for all her work. And yeah, as Franziska said, she'll obviously continue and specifically help us with the DEI efforts that she's putting into the diversity session and so forth. Right, so outgoing, incoming working group chairs. There were a few changes this time. I'd really like to thank Birge-Lee. She's not here, but she, together with Curtis, has chaired the RIPE NCC Services Working Group pretty much from the beginning. So I'll thank her again next time when I see her. So I can't give her a gift back right now. The other chair who's been running a working group pretty much from the beginning was Martin Winter, who kicked off together with Ondrej, Filip, the open source working group. Was it RIPE 66, I think you said, during the working group. And you're now stepping down and handing it over to the new team, so to speak. I have also a gift for you. Morning exercise. Thanks very much. And then we have, I have some more names on there and some more pictures, and maybe going to the right. Paul Hofstetter actually is not technically stepping down. He's been selected to start at the the Connect working group as a co-chair last time and agreed to help the new team in the routing working group. So he'll step down from the routing working group, but will continue in the Connect working group from now on. And then there were also some changes in the Cooperation working group. Achilles and Jolf's term ended, but they were actually selected back in. So here you'll see some of the incoming chairs or back, selected back in chairs. So Jolf and Achilles will continue in the Cooperation working group. Then we have Stefan Wahl, who will be taking over from Birge-Lee in the RIPE NCC Services group. We'll have Marco Dittrich, who will take over from Martin in the Open Source Working Group, and Sebastian Becker, who will start as a co-chair in the Routing Working Group. So you'll see some new faces there also in the number of working groups moving forward. Yes, thank you. It's actually great to see more volunteers stepping up for various community functions. I'm really pleased to see that. So here's the whole picture and whole picture gallery of all the working group chairs that we currently have in place that you will see again next time. Then to the next important community committee, it's the program committee. Here are the people who put together the program for this, the plenary sessions for this meeting. Thank you all very much. It was really, I had really good feedback about the plenary sessions, so thank you all. And unfortunately, Moin is leaving the PC. His term was up and he was not re-elected back in. So Moin, where are you? Are you in the room? There you are, all the way in the back. I also have a gift for you. And there's always the next term, of course, the next selection if you want to come back. That means we'll have, so there were 2 terms, and there was Antonia, who was actually re-selected back into the PC, re-elected, and the new person on the PC will be Babak Farouki, who will take over from Moin. So also congratulations to you, and thanks for all the other candidates who were standing. We had quite a large group of candidates, which is great. Right, just a quick reminder, please await the talks that will help all the, the PC and the working group chairs to plan for the meetings ahead, and will also give valuable feedback for the speakers, because some of the comments, can be shared with the speakers for about their presentations as well. And another QR code here for a survey. It seems to be the theme for this week. Fill in the survey. So we would really like to receive your feedback in general. And I already had, of course, I'm also, happy if you come to me or to any of the organization team to give us feedback in person. I took lots of notes during the week. Last but not least, a big thanks to the host and the sponsors. And I have something special for the host. Ondrej, pay attention. Please come up to the stage. Don't distract him, CK. You can do it. Yeah, you do it.
Thank you, Ondrej.
So we have a plaque here for Ondrej, Filip, who's the local host, who gave us this wonderful meeting here and also contributed to the dinner last night. Is this a certificate? Do you want more hands? Will one say something? No? Okay.
Maybe. Just thank you all for coming. I hope you enjoyed the meeting here in Prague, and I hope it's not the last time we will meet in this lovely city. Thank you so much.
Okay, thank you. And we have one more certificate, I believe, for the diamond sponsor. I don't know if anybody's here from AAWS to take that. Yeah, there, Clara's running up on stage. I mean, we really couldn't do it without the sponsors. I'm very pleased to see also returning sponsors for the meetings. And of course, a big thanks to all the other sponsors. And last but not least, the RIPE NCC team, and specifically Kajal. Come up. I don't have a gift for Kajal. I give it to her in Amsterdam. But no, this was the first meeting that Kajal was running kind of independently and responsible for everything. And I heard only positive comments about the dinner last night and the venue, and she did a fantastic job. So thank you very much. And that brings us to the end of this meeting, and looking forward to the next meeting, which we will have in Lisbon in May. And we'll have a short video from the local host who will have us there and who will help us out in Lisbon. So I'm very pleased to welcome Eugénio Pinto from .pt.
Hello, everyone. Can you hear me okay?
Yes, we can.
Good morning. So we are concluding the RIPE 89, and I'd like to express my appreciation for the remarkable discussions and collaborations that have taken place over the past few days regarding address policy, DNS, Internet of Things, IPv6, cybersecurity, and many others. The RIPE community is renowned for its inclusivity, bringing together diverse voices and perspectives from across the internet community. And it's my pleasure to announce that the RIPE 90 next May will be hosted in sunny Lisbon. May is a great month to be here. Lisbon is a vibrant city, and the Portuguese people are known to be very welcoming. I'm certain that you'll have a wonderful time. And you'll certainly enjoy visiting some of its iconic attractions, like the historic monuments of Belém, and probably eat some pastéis de nata, and experience the vibrant nightlife of Bairro Alto. But also in the surroundings of Lisbon, you can find the beautiful scenery of Sintra and the refreshing beaches of Cascais. For the ones that like to go surfing, there are nice spots there. It's going to be great to have you here, and we look forward to continuing the conversation, sharing new ideas, and building on the progress that the community has made in Prague. On behalf of .pt, the CCTLD of Portugal, I extend a warm invitation to all of you to join us in our home. Thank you all, and see you in Lisbon.
Oh, sorry. One thing I was reminded, actually, you can go to the RIPE 90 website right now and register if you're keen coming back. So registration is open already as of now.
If anyone's trying to get registration number 1 for RIPE 90, I have bad news for you. That is reserved in the system. Not for me. It's not. You changed it. Is there a piece of policy that allowed you to do that? Right. Oh, you have 2. Oh, God. 42. Oh, that's a better number. Good. Welcome to Tron. Oh no, wait. I mean, I was a little bit confused with the AV here in the room this week. Welcome to the secret working group. Concise, complete, and consistent, and most of all, secret. What does secret mean? I have to spell this out every time, but secret means no pictures, no texts, no Facebook, no Telegram, no Twitter. Yes, Twitter. No YouTube, no Instagram, no TikTok, no WhatsApp. Fill in any other 5 of your social platforms, and not why. Don't ask me why. So starting off with this meeting this week, we got challenged. Choose wisely. I think is a pretty bold question to ask this room to begin with. And it had to do with our vertical transportation throughout this venue, the elevators. We were told to choose wisely between the left door of IPv4, which is depassed, and IPv6, which still apparently solidly remains in the future. And I'm somewhat confused that some people actually were vocal about intentionally waiting for the V6 elevator to show up. I am actually a very, as they call it in this community in the IETF, a very happy eyeballs kind of person. I'll just take the elevator that shows up first. But actually, the whole thing was a bit of a confusion because the sign was in the wrong place. Because this is actually where it was supposed to be. And I think that at this point, it's a far more relevant question to ask. To smooth a short tale of orbital mechanics. So you have the sort of normal of a RIPE meeting, which is this dot in the middle. And then usually most RIPE meetings sort of orbit around that. They're sort of going around normal, but never quite reaching it. And some of them get closer to normal than others. Some take some weirder orbits around it. And some meetings, numbers omitted to protect the guilty, get a little bit more bizarre. And then there's this one. And there's a problem with orbits that are happening inside of planetary bodies. They exist in theory, but in practicality, they are rarely stable. So I'm looking forward to maybe a little bit less normality for future RIPE meetings again. I think we would all do well with that. So normality will be resumed shortly.
Rest assured. At this meeting, all things aligned, no chaos or mishap to find. So smooth and so clear, almost too near, too perfect, yet calmly designed.
And there's another thing, I referred to this last time. We have a bit of a namespace collision. One of the working groups that I will not name has decided to rename itself. Not looking at anyone right now.
We warned them.
I won't say I told you so. So there is a bit of a TLA snafu. Jan.
Confusing security with secrets quite dire. You might lock up what none would acquire. What's safe for all eyes gets hidden with lies, while real secrets get set on fire.
So I might actually get this wrong and mix this up. I have no idea how it could be. Then next, which is, I think, very appropriate for 2024, the program committee introduced AI guidelines. And I was extremely pleased to hear that the program committee got to that point. And actually, I'd like to highlight one of the statements that was made during that presentation, which is adding AI generated content at the last minute does not make your presentation better. Well, the program committee, to which the secret working group says, well, it depends. More specifically, Sparky is disappointed. Sparky did not get a mention in the AI guidelines, but Sparky is okay with that. But Sparky is very disappointed that the opportunity was missed to mandate watermarking of AI-generated content in presentations, which we really feel, and the secret working group has been consistently doing for the last 6 meetings at this point, or something like that. So Sparky was very disappointed. Well, and we'll have a conversation with him and probably give him some candy and see if that gets any better. Then Game Up. I mean, Tron was a game. It was, I mean, if you never watched the movie, probably don't. The remake in 2010 was actually much better and had much better graphics. So we're looking at renewing the community. That's been sort of an ongoing thing. And we need a younger crowd, and we want them to stick around. And obviously, the solution here is gamification. And what's the best incentive that we can offer as a community? Of course, it's badge upgrades. So here we go. So if you're here, and this is like your first or second or third meeting, you just get like the badge that all of you got. And then from basically the fourth meeting on, you get a more civilized script on your badge, right? I mean, a little bit more distinguished. So everyone knows that you've been here coming along and doing this thing for a while. Then after of course, more than 10 meetings, you get a nice cursive to go on your badge and make you look more distinguished. And then by the time you've done more than 20 of these, I mean, you're more of a Courier New kind of type anyway, probably. So you're going to get a font that properly reflects your status and maybe your age on your badge. And then, of course, if you've been reading this for a very long time, and I'm embarrassed to say I'm about to hit that mark myself. Then after 50 plus meetings, and the people who get this badge know why it looks like it looks, and I'm not going to explain it any further. But that's not all. That's not nearly all. That's just the start, right? I mean, if you play a computer game and you customize your character, some of the computer games, half the game is customizing your character, and of course your badge is no different. So here's another thing. So you have your badge, and then every time you successfully complete a session, you get a star. And you do another one, and you get another star, and you know, and then everyone can see that you have been diligently following the proceedings, which is great. But that's not all, of course, because at the time you start making contributions, you go ask a question on a microphone. I mean, then here's a crown. You get a crown. And another one. I mean, and maybe you will even stand up on stage at some point. You'll do a presentation, and you get another crown. And of course, there's more to this. There's a community sense of this. And so you collect points by doing community stuff, like, I don't know, finding all the board members at a meet the board session, instead of just running to the bar and getting a drink. Talk to newcomers, right? Rating talks. And if you collect enough points, then you get a different background on your slide. I mean, you get a nice holo. And if you keep doing that, of course, you upgrade further, so you get to a foil. And then ultimately, if you are the absolute top tier community member, then finally, of course, what else is there than the gold glitter? So I'm looking forward to seeing this on the right badges from the next meeting on. And of course, there's a whole bunch of hidden awards and unlocks that I won't be talking about, but I might reference in the future. What else? This is, looks like I forgot a title here, but no. This is about non-existing things. Which, as we are a distinguished lot here, every secret working group session has a sonnet, and so we have a sonnet. Nigel, you have the floor.
The way it used to be does not exist. It is a construct of the sleeping mind. The sort of thing a Czech says when he's pissed and when he tries reality to find. These things do not exist, and so believe in them the national psyche to him calls, a tissue finely stretched of unseen weave, knits past and present, shuttered shopping malls. Imaginary poets, long dead kings, thrice layered public holidays, but bars are never closed and many other things engage his passion looking to the stars. Our local host bids welcome to us all, the sane, insane, and long, and short, and tall.
So if you're wondering what the 3 layers of public holidays were about, this was part of the presentation that the host did during the opening, where Ondrej very helpfully described the layers of public significant days they have here in Czechia, and ended up with saying, don't panic, there is no level 4. However, Czechs like non-existing things. So who says that the list stops at 4? So what he didn't talk about, but what the Secret Working Group uncovered, was level 5. And I mean, it's sort of a little bit like this. It lacks description. Talk to any Czech person about a level 5 public holiday, and they might come up with some language around that. So that, and then we ended up last night with a night at the museum. And I was very, very looking forward to that. It's easily one of my favorite series of movies. So that sounded awesome. Halloween and a night at the museum. It's like a movie script. Oh, wait. So where do we go? Well, it was the peak of civilization. It's a very nice looking venue. It had a string quartet. It was beautiful. It was the absolute summum of what we can achieve as a community, or maybe not. But the one thing that really saddened me was the dinosaurs did not move. They stayed stuck in their glass cages. I have no idea what this picture is doing here. But more importantly, this came to the attention of the Secret Working this summer. Some of you might recognize some of the people in this picture. We've reached the point of this community where we have people in this community who get streets named after them. I have no qualitative thing to say about that. It's just a thing I would very much like to observe and share with all of you. And then no presentation at RIPE 89 would be complete without a QR code. So please don't forget to fill out our survey. I think you will appreciate what's in there. There you go. Word to the wise from the security part of the Secret Working Group. Do not randomly make pictures of QR codes that you don't know where they go to. And that concludes my presentation for this time. I would love to see you all in Lisbon. See you next time.